we're going to look at the idea of compound interest. And almost everything that you do with a bank these days is compound interest. When you take a loan, it involves compound interest. When you set up a savings account, it involves compound interest. When you make a retirement account, it is compound interest. So the first problems we're looking at are very simple compound interest problems, although it won't seem that simple to you in respect to the problems we're going to get later this week. You'll see that they do seem a little bit simpler than those. All right. With these, we're going to make one deposit, just one amount. So when you see the words compounded in a problem, and you're only depositing or you're only getting a loan for one amount, and there's no monthly or weekly or yearly payments being made, then we've got a compound interest problem, and we're going to use the formula that we've got here. So let's take a look at this formula. The amount P sub n obtained from P sub 0 compounded k times a year for n years at interest rate R is given by P sub n equals P sub 0, 1 plus R over k raised to the nk. So it's important that we just note a few things, and it may help you in your notes to do this. What we have here will be our final amount, or sometimes it's called future value. So, future value. Whereas what we have here is what we start with. So starting value. The amount of money that we start with. And then R, of course, is our interest rate as a decimal. Hopefully you write much quicker and easier, more readable in your notes than I do on here. K is the number of times compounded per year. So, number of times compounded per year. And then finally, N, capital N, right here, is the years, number of years. All right, so we're going to do two problems, and we'll work our way through this formula. And we'll solve them step by step so that you do the right things in your calculators, because that's usually the biggest mistake people make, is to enter things incorrectly in their calculator. So you deposit $2,000 in an account earning 3% interest compounded monthly. Question A says, how much will you have in the account in 20 years? Okay, so let's identify everything that we know. All right, our $2,000 is the initial amount that we're going to deposit. So it's our starting amount. It's P sub 0. So P sub 0, first of all, is $2,000. The 3% interest is our interest rate, so that's R, but we always change it into a decimal by moving it 2 places backward. Compounded monthly. Now, if we think about monthly, that's 12 times per year. So our K is 12. And then our capital N, the number of years, is 20 years. So let's plug all that information into this formula. Now we don't know P sub n, that's what we're going to figure out. So that still stays a variable. P sub n, but we know P sub 0 is 2000. Oops, 1 plus R is 0.03 divided by 12. And then we're going to raise this to the 12 times 20 power, nk. I'll put it in the order of the formula, n times k. All right, now let's talk about working this thing out. First, we're going to do two things at once. We're going to put all of the inside of the parentheses into our calculator. So I'm going to put 1 plus 0.03 divided by 12 into my calculator first. I get 1.0025. Now the next thing I'm going to do is I'm going to multiply this exponent, 20 times 12. So if I do that, that's really the 240th power. So this 1.0025 is raised to the 240th power. Now, using our order of operations, we've got to do our exponent first. So we've got to take our 1.0025 and raise it to the 240th power. And if I do that, I get 1.820754955. Now you'll notice I'm putting all of the decimals that my calculator gives. It's very important to do this until we get to the final step. Otherwise, we get really quite far off in accuracy if we're not careful. So now I'll multiply those two together, and I get 3641. And I will go ahead and round to cents at this point, and 51 cents. Okay? All right. So notice that we started with $2,000, and in 20 years we only have 3641. Not very much. If you do this and you start with $2,000 and you end up with $1 million, you know you've done something wrong. If that were possible, we would all do it, and we'd all be much richer for it. So realize that if you get a really huge number when putting things into your calculator, you've put something in wrong. And the chances are that the error you've made is right here. It's so important to do this step where you multiply those exponents together. All right, now let's look at B. How much interest will you earn? Well, let's remember that we started with $2,000. So all we need to do is take the final amount and subtract the $2,000 from it, and we actually earned $1,641.51. Okay? All right, so let's look at a second example. You deposit $10,000 in an account earning 4% interest compounded monthly. How much will you have in the account in 25 years? Okay, so let's again identify everything that we have. The initial amount we're putting into the account is our P sub 0, and P sub 0 is $10,000. All right, our interest rate, R, is 4%, expressed as a decimal, that's 0.04. Our number of times that we are compounding, well, we're compounding monthly, so that's 12 times per year. So K is 12. And we're going to do this for 25 years. Okay, so let's plug into our formula. Again, we don't know our P sub n, that's still going to remain as a variable. But our P sub 0, which is first in our formula, is 10,000. And then 1 plus R over K, so 1 plus our R is 0.04 over K, over K, which is 12. We want to raise that to the NK power, to the 25 times 12. All right, again, let's work this out. Let's be careful. Let's do all of the inside of the parentheses in our calculator. So 1 plus 0.04 divided by 12. That gives a repeating decimal, 1.003333333333. Again, take it out, lots of decimal places. Let's put 25 times 12 into our calculator, and that gives 300. So this is raised to the 300 power. And now let's go ahead and do exponents before multiplication. So I'll leave the 10,000 alone, and I'll put 1.0033333333 raised to the 300 into my calculator. And that gives 2.713765131. And now I will do the final multiplication and multiply that number by 10,000, which is going to give 27,137. 137, and I'll go ahead and round it to cents now, and 65 cents. Let me put an equal sign in there. So our 10,000 in 25 years turned into 27,000. All right, how much interest will we earn? Well, again, let's just take the amount that we got at the end and subtract off the amount we put in. We get that we earned $17,137.65 in interest.